Welcome back. Okay, today we are working in our workbook starting on page 208. So take your workbook out and let's take a look at 208. Okay. All right, the scientific name for the little bumps on your tongue is fungiform papillae. Fungiform papillae. Each bump can contain many taste buds. The number of taste buds a person has varies. There are three general classifications of taste. There are super tasters, medium tasters, and non-tasters. Suppose a super taster has 8,640 taste buds, which incidentally is almost 3 times as many toothpicks as Abel has. Okay, that's not really significant, but okay. Solve the equation 4.5n equals 8,640 to find the number of taste buds n a non-taster may have. That's kind of a mouthful, no pun intended. Okay, so a super taster has 8,640 taste buds, which is 4.5 times what a non-taster has. Okay, so the equation then is 4.5n, n stands for the number of taste buds a non-taster has, equals 8,640. So solve that equation. Number 33, model with math. In one study, the number of women classified as super tasters was 2¼ times the number of men classified as super tasters. All right, now suppose 72 women were classified as super tasters. Write an equation that represents the number of men, using the variable m, who were classified as super tasters. Then solve the equation. How many men were classified as super tasters? Remember, 2¼ times more women are classified, 2¼ times the number of men are classified as super tasters for women. All right? Okay, solve those two and pause this and then come back when you are done with those two. Okay, so n equals, the non-tasters have 1,920 fungiform papillae. And then for this one, the equation I used is 2.25m equals 72. And then when I solved that equation, I did it by dividing both sides by 2.25, and I get 32 men. Okay? All right. Now, number 34. A fraction, represented by f, multiplied by 5 equals 1/8. Write an algebraic sentence to show the equation, then solve it and explain how you solved it. So read it carefully, set it up, and solve it. Then we've got Yelena, who needs to swim a total of 8 miles this week. So far, she swam 5 3/8 miles. Use the equation 5 3/8 plus m equals 8 to find how many more miles Yelena needs to swim. So you see how they're setting this up here, and here's one of those, I know what you're thinking. You're thinking, Miss Williams, why don't you just say 8 minus 5 3/8? Yeah, you're right. But this gives you some good practice with the algebraic equation. Okay, number 36. Can any equation that is written using addition be written as an equivalent equation using subtraction? Explain your reasoning and give an example containing decimals that shows your reasoning. So if it's an equation with addition, can you make an equivalent equation, an equation that has the same value but that is using subtraction? And then do an example. Okay, critique reasoning. Oscar is 12 years old and his little sister is 6. Oscar uses A to represent his age. He says that he can use the expression A divided by 2 to always know his sister's age. Do you agree? Explain. Okay, pause the video here and solve those ones, and come back and we'll check your answers. All right, so if this is how I set up this equation, 5f equals 1/8, and then I divided both sides by 5, and I got f equals 1/40. And I also made a little note here. You would also get it correct if instead of dividing by 5, you multiplied by the reciprocal of 5, which is 1/5. Okay? Now, Yelena needs to swim 2 5/8 more miles to reach her goal for the week. That is a lot of swimming. Okay. 36. Can an equation written using addition be written as an equivalent equation using subtraction? Yes, it can. They are inverse of each other. So, for example, 2 plus n equals 5 is the same as 5 minus 2 equals n, or the other way around. So yeah, you can do that. Sorry, Oscar, you cannot use that expression to always be correct about your sister's age, because right now it would work because you are exactly 2 times as many years old as she is, but next year you're going to be 13 and she's going to be 7, which doesn't fit that expression anymore, because 13 is not twice as many as 7. Okay, now these last 2 here, which is the solution to the equation below? For both of these, gives you choices. Here's the equation. Which is the solution? Do those 2. Pause the video here. Come back and check your answers. Okay, here it is. For number 38, letter C, y equals 2 6/10 is the answer. And for 39, letter D, x equals 485 thousandths is the answer. Okay, good. Let's move on to the next page. All right, first one is about vocabulary. Describe the relationship between equations and the properties of equality. So you'll notice these next couple of pages are kind of reviewing what we've been working on. And then for this one, write an equation for the situation, then solve the equation. So this is all kind of review. A fraction f multiplied by 4 equals 1/2. So it's kind of like these are as if you wrote it out in words, and it's asking you to write it out just with the numbers as an equation. Same thing here. When 832 is divided by n, the result is 16. So the result, what symbol are you talking about there? Equals. The result is, another way to say that is equals. When 10 is subtracted from x, the result is 6. 10 is subtracted from x, not 10 minus x, but x minus 10. Okay, so do those first 4 problems. Pause the video. Okay, let's take a look at those. All right, you can use properties of equality to solve equations. That's what the relationship is. You use these properties to solve those equations. Okay, and for this, 4f equals 1/2. That's the equation. Then I multiplied both sides by 1/4. I could also have divided both sides by 4, but in this case I was using the reciprocal and multiplying, and I get f equals 1/8. When 832 is divided by n, the result is 16. So that looks like that, and the answer is n equals 52. For this one, when x is subtracted from from 10 is subtracted from x, so that's x minus 10, the result is 6. The answer, x equals 16. All right, and then for these ones, which equation is not equivalent to n minus 9 equals 12. Select all that apply. So you have to look at all of these equations, and you're looking for equations that are not equivalent to n minus 9 equals 12. Okay? And then for number 6, which value for d makes the equation 9 equals 18 divided by d true? It says select all that apply. So think about whether there's more than one there that you could select. And then finally, number 7, the area A is a parallelogram. The area A of a parallelogram is 15.3 square centimeters. Its base is 4.5 centimeters. And the formula for finding the area of a parallelogram is A, area, equals B, which stands for base, H, which stands for height. Here's the height of the parallelogram right there. So write and solve an equation to find the height, H, of the parallelogram. So you've got the area, you know the value of the area, and you know the value of the base. So you're solving for the height. Okay, go ahead and do those problems. Pause the video and come back when you're done. All right, here we go. So this one is not equivalent. N minus 9 plus 12 equals 12 minus 9. That's not equivalent to that. And also this one, n minus 9 plus 9 equals 12 minus 12, also not equivalent. And then for this one, there are two values that would make that equation true. 2 is one of them, and then 10/5, because 10/5 equals 2. So that would also be a possible solution. Now for this one, here's how I set up that equation. 4.5h, right? That's the value of the base times the unknown equals the area, which is 15.3. So the height turns out to be 3.4. If you divide both sides by 4.3, you will get 3.4. All right. Check your work. If you made mistakes, try to catch them. You can also leave me questions in the comments or shoot me an email, or you could save your questions for our small group meetings during the week. All right, you guys, you're doing awesome. I will see you next time. Bye.